Page 546, lesson 9.1 is on quadratic graphs and their properties. Quadratic graphs, what that means we'll be talking about is called parabolas. So instead of straight lines, we're going to have lines, well, not really lines, we're going to have graphs that are curved. So if you look at the key concept box, we've talked a little bit about before, if you have the highest exponent is to the second power, we call that quadratic, and we're going to learn more about that in this chapter. So quadratic function we can write in the form y equals ax squared plus bx plus c. And the deal is, it says where a is not equal to 0. So like, you know, obviously if we had 0x squared, I mean the x squared is not doing anything. So we want to have some number next to the x squared, or if it's just a plain x squared, that you could put a 1 next to it, that'd be fine also. So here's some examples of quadratic functions. If you'll notice in the first two examples, well, the first example, really they only had a squared term, y equals 3x squared. They didn't have an x term, they didn't have a constant, and that's fine. We can have that and it's still a quadratic function. The middle example, now they have a constant and the squared term, but they don't have the x term. That's fine. And then the last case, they have all three of them, and that's fine. Okay, again, the thing about quadratic function, what makes it a quadratic function is that you have an x squared term and you don't have anything higher than that. You don't have any higher power like x cubed or anything. X squared is the highest exponent that you're going to have. So when you graph these functions, it's going to be a U-shaped graph. It's either going to be a U or it's going to be an upside down U. So it's going to look kind of like this maybe. And we'll talk about, you know, how do we know if it's going to be a U or an upside down U. We'll talk about that later. What happens when we graph these is these graphs are symmetric. So we have on these problems what's called an axis of symmetry, or sometimes it's called a line of symmetry. Okay, so these are synonyms, and some books call it an axis of symmetry, some call it a line of symmetry. So if you hear me say line of symmetry, that's the same thing as the axis of symmetry. So what that does is that divides it into two matching halves. Okay, two matching halves. So basically, if you think about if you would fold this on that axis of symmetry or the line of symmetry, the two parts would match up with each other. Okay, that's what it means by being symmetric. So in this case, the y-axis would be our line of symmetry. So if I would fold right on that line, these two parts would match up with each other exactly. So on a parabola, we have some special names for some things. The highest or lowest point on the parabola is called a vertex. Okay, so this is a different definition of vertex. We've talked about a vertex or vertices before with three-dimensional figures, and those were like the corners of our three-dimensional figures. So this obviously is not a three-dimensional figure, but it's the highest or lowest point in the parabola. And the deal is, if the parabola, if a is greater than 0, so if this is a positive number here next to the x squared, then the parabola is going to open upward. It's going to be like a U shape. And if it opens like that, then the vertex here is going to be the low point. It's going to be the minimum point on our graph, the lowest point that it gets. Okay, so for example, if we had y equals 5x squared minus 7. Okay, since we have a positive x squared term there, that would be a parabola that would open up. Okay, so we say a is greater than 0, which means a is positive, right? So an analogy that I use to help you remember this, if it helps, a is positive, so this would be maybe somebody is positive and they are smiling. Okay, that parabola is smiling. Okay. If we have a is less than 0, in other words, a is negative. So for example, maybe we have y equals negative 3x squared plus 5x plus 9. Okay, it doesn't matter what the signs of your x term or your constant are. It's just the sign of this x squared term. So if the sign there is negative, then the parabola is going to open downward. It opens downward like this, which means our vertex is going to be the highest point. Okay, and again, that vertex is right on that line of symmetry. Okay, it's going to open downward, and so the vertex is going to be the maximum point. It's going to be the highest point on the graph. Okay, so similar analogy, a is negative, so this parabola is frowning. Maybe if somebody's negative and they're frowning versus somebody's positive and they're smiling. Okay, again, just a way to help you remember these things. So if we look at problem 1, they're asking for the coordinates of the vertex of each graph and whether it's a minimum or maximum. So what we're trying to do is look for kind of where our line of symmetry is first, or axis of symmetry. So it looks like it's here on A, and then from there we can look at what our vertex is. So it's the point that's on the line of symmetry. So there's the point on the line of symmetry. And so that point would be 0, 3. And it's the highest point, so it's the maximum. 0, 3 is the vertex, it's the maximum. On part B, same idea. This time it doesn't look like it's quite lining up on the y-axis though, but looks like it's actually over here. So this would be our line of symmetry or axis of symmetry. And so then this would be our vertex. So this time that vertex is at the point 1, negative 1. And it's the lowest point on the graph, so it's a minimum. So if we look at the got it, number 1, same questions. So for finding our vertex again, let's try to think about where this would split in half, where our line of symmetry or axis of symmetry is. Looks like it's there, and so that vertex is at -2, -3. And then since this is the lowest point on the graph, then we would say it is a minimum value. So here's some information about graphing quadratic functions. First of all, again, a quadratic function is ax squared plus, that should be bx plus c if a is not equal to 0. And normally we're talking about actually quadratic equations, would be like y equals ax squared plus bx plus c. Again, the graph is going to be a parabola, so it's going to be either like a U or an upside down U. If A is positive, it's going to be a U. If A is negative, it's going to be a upside down U or a frowny face. Vertex is the highest or lowest point on the graph, and it's always on the line of symmetry or the axis of symmetry. And then on the graph, a reminder here about these ideas. The domain is the possible x values, and the range is the possible y values. So sometimes when they have us graph these, or if they have us look at a graph, they might say, what's the domain of this function, and what's the range of this function? And we have to look at, we did that interval notation before, where we looked at kind of from the low to high what our x values can be and what our y values can be. So here again, just an example of what this might look like. Line of symmetry and vertex. We have graphed lines before, and when we've graphed lines, usually we found 3 points. The third point was kind of a double check to make sure all the points lined up. The problem is with graphing a quadratic function is it's curved. And so if it's curved, then it's really better to have more points than that to be able to tell exactly what the graph is doing. So what we're going to do, the first thing when we graph these quadratic functions, is we need to find the line of symmetry. And the line of symmetry is going to be on this line, x equals negative b over 2a. All right, and again, that goes back to that idea we talked about earlier, that it's y equals ax squared plus bx plus c. So this is, the b and the a are coming from that equation. So basically they're going to give you an equation and they're going to say, graph this. So this is what we're going to have to find first, that line of symmetry. What is the line of symmetry, or what is the axis of symmetry? Then we're going to find the vertex. So the vertex, I've got this listed like it's the coordinates of a point because that's what it is. The x value is negative b over 2a because the vertex is always on the line of symmetry. So once we found what the line of symmetry is, that's going to be the x value for our vertex. And basically we just substitute that back in the equation and then figure out what the y value is. Besides the vertex, we are going to find 2 points and their mirror images. So that's going to give us a total of 5 points. We've got the vertex, we've got 2 points plus their mirror images. Okay, is a total of 5 points. With 5 points, that's going to give us a pretty good idea of what this parabola is doing, what this graph is going to look like. Again, it's a little bit more going on than just a straight line, and so we need more points to be able to graph this well. So if we look at the next part in your book, kind of just some things that we've already talked about. One thing is in particular though, if we have graphs that are in the form y equals ax squared, in other words, there's no x term and there's no constant, then the vertex is going to be at the origin. So like, for example, if we had y equals 5x squared, or if we had y equals negative 1/3 x squared. Okay, those would be examples where the vertex is at the origin, because the deal is when you go to find that line of symmetry, you think about it, it's negative b over 2a. Well, b is the number next to our x. We don't have an x, we just have an x squared. So that's going to be 0. So 0 or negative 0 over, I don't really care what, it's going to be 0 every time. Okay, so that's why the line of symmetry or axis of symmetry is always x equals 0, which is the y-axis. And then that means we'd put a 0 in for x. Well, if you put a 0 in for x, you're going to square 0, which is 0, times whatever number is going to be 0. Without that constant at the end, the y value is just going to be 0 as well. So that's kind of a shortcut for you if you memorize that, and then you don't necessarily have to go through all the steps of, what is my line of symmetry, what is my vertex. It's just automatically going to be that. So if you look at problem 2, they want us to graph this y equals 1/3 x squared, similar to my one example I just gave there. And then they're also asking what the domain and range are. So automatically, since there's no x term and there's no constant, automatically our line of symmetry is the y-axis, or x equals 0. Okay, x equals 0. And I'll abbreviate sometimes line of symmetry like that, is x equals 0. And then our vertex, if you put a 0 in for x, it's going to be 0. So that's kind of just automatic, like the book said. So that's kind of a starting point. And then we have to find some other points. So the book put a 3 in for x. 3 is a good choice because we've got that 1/3. Kind of like when we graphed lines, we wanted to do multiples of that denominator. So you put a 3 in for x, and so 3 squared is 9. So we've got 1/3 times 9. That'd be 9/3, which is the same as 3. So 3 would be another point on the graph. And then they put in 6, which is the next multiple of 3. So 6 squared is 36. So 36 divided by 3 is 12. So 6/12 would be another point on the graph. And then what the book's saying is let's reflect those points. So in other words, if we reflect across, in this case, it makes it easier because it's the y-axis. We're going to be the same difference away. So if we were at 3, 3, that'd be 3 units to the right. 3 units to the left would be negative 3, 3. And then same thing for our other point. We were at 6, 12. So 6, 12. This is 6 away from our line of symmetry, so we should be 6 away over here, which is negative 6, 12. Okay, again, if that line of symmetry is not on the y-axis, it's not always just going to be, oh, I just changed the sign of my x value. Okay, that's not always going to be the case, but in this case, that's what it is. All right, so those are our reflection points. That gives us 5 points, and then that's going to be our graph. And then the domain and range. Domain is possible x values. So if you look at the equation, we're just really thinking about, is there any number I could not put in place of x here? And the answer is no. I can put any number in place of x that I want. So the domain would be all real numbers, or like we talked about earlier with interval notation, we could say it's negative infinity to infinity with parentheses on the ends there. And then the range is the possible y values. Okay, so possible y values, what you want to do for the y values is go from low to high. All right, this is how I learned on tennis, how you're supposed to, when you swing the racket, low to high. So that's what I always think about when I do this. But anyway, we start with the lowest y values and work your way to the highest y values. So as I'm going from the bottom of the graph here, as I'm going from the bottom, I'm going to go until I get to a point. So there it is. That's my first point. And that y value is 0. So 0 is my lowest y value. And then you can see this just keeps on going up forever. So the range, we could say, is from 0 to infinity. Notice, again, we talked about it earlier, a bracket there on the 0 because it includes 0. So starting at 0, going all the way to infinity for the range. So if you look at the got it number 2, they want us to graph this function, y equals 3x squared, and they're asking again, what are the domain and the range? So this would be something we can do, probably would be good to do on graph paper if you want to sketch it out in your notebook, otherwise you can. So this is like the example that they just went through in the book. We don't have an x term, we don't have a constant. So our line of symmetry is going to be x equals 0. And again, you can go through the process if you want. We don't have a b term, we don't have an x term, so we don't have a b. So it really doesn't matter. Whatever it's going to be is 0. So x equals 0 is our line of symmetry. So then our vertex is going to be on that line of symmetry. So our vertex is going to be 0 something. If you put a 0 in place of the x here, first of all, I'd do the exponent. So 0 squared, 0 times 0 is 0. And then negative 3 times 0 is 0. So 0, 0 would be our vertex, which is what they mentioned to us earlier. There's no x term and there's no constant. Line of symmetry or axis of symmetry is going to be x equals 0, and the vertex is going to be 0, 0. So now we need to find some other points for our graph, so we'll start replacing x with some different values and see what happens. There's no fraction here, so 1 would probably be my next choice to go to. So if I put a 1 in place of the x, 1 in place of the x, and then I should get negative 3. Try to cover up what we haven't seen here. Okay, so we put a 1 in place of the x and we get negative 3. Remember our equation was y equals negative 3x squared. And then if you want to, you can go ahead and find the mirror image of that point. So 1, negative 3, that's 1 unit to the right of our line of symmetry. If we go 1 unit to the left, then that would be negative 1, negative 3. Then another point we might want to try would be 2. Just it's another easy number to work out. If you put a 2 in place of the x, so 2 squared is 4. Negative 3 times 4 is negative 12. So that would be the point 2, negative 12. And again, that would be 2 units to the right of our line of symmetry. We go 2 units to the left. In this case, happens to be negative 2, negative 12. Like I said, it won't always be just opposite x values, but that's how it's going to be if we have a y-axis for our line of symmetry. So that gives us 5 points then. So that would be, then we could graph. So here's what the book did for their graph. Notice they're going by 3s, which is, at least on the y-axis, they're going by 3s, which is pretty good with the numbers they've got there. If you went by 1s, that's fine. It's just, going to take you a little bit longer to get to that negative 12. When you graph these, just a couple reminders. One is that this should be like a U shape. Okay, it's not a V, it's a U. And then also make sure you remember to put arrows on the ends. So at least go a little bit past your endpoints and put arrows on the ends of your graph when you do that. So then looking at the domain and range, domain possible x values. This thing's going to keep expanding to the left and to the right, okay, very slowly. It's obviously going down a lot quicker than it's going left to right, but the domain is going to be all real numbers, or if interval notation, you could say the domain is negative infinity to infinity. And then the range is our possible y values. So the lowest y value, kind of if you think of starting at the bottom of the graph here, this goes down. These will keep going down forever to negative infinity, and then keep going up until you don't have any more points on your graph. So here's our highest point. The maximum is at our vertex there, which is where the y value is 0. So our range is, if you did interval notation, the range would be from negative infinity to 0, and we'd have a bracket on 0 because it includes that. Or you could say y is less than or equal to 0 would be another way of putting that. So it's going to be one of these options here for the range.